The last couple of days, we looked at limits graphically and with a table. What we noticed was there were times where we could just take the value we're approaching. So, for instance, this the limit as x approaches 3. There were some of them where I could just take the 3 and substitute it in and get the value, but it didn't work on all of them. And when it doesn't, then we have to go about it a different way. So direct substitution is a possibility. But if you get 0 over 0, that's a problem. Doesn't mean that the limit doesn't exist. So that's what we're going to look at today. It says, suppose you're asked to find the following limit. The limit as x approaches 3, this right here. If I substitute in 3, I'm going to get 0 over 0. And so that's a bad thing. So it says direct substitution is not possible because 3 results in 0 in the denominator. However, this does not mean that the limit does not exist. All right, so if you do direct substitution, you get 0 over 0, doesn't mean it doesn't exist. We saw that with the graphs. So if f of c produces 0 over 0, like in the example, it's described as having an indeterminate form. All right, so there's some vocabulary for you, indeterminate form. In this case, we can apply other algebraic techniques such as factoring or rationalizing to divide out a common factor. So this is also called the dividing out method. Right? So that's what we're going to do. A whole lot of factoring and rationalizing to do here. So it says to evaluate each limit and verify with a graph and a table. We're not going to take the time to evaluate with a graph. I think you can just take my word for it. And then if you want to go back and verify it with a graph later, you're welcome to do that. Notation is important when you're showing your work. So on the AP test, you get points for steps and stuff. And if you skip things, you might be skipping something that, it's okay to skip steps, but you have to make sure all the important stuff is there because you might lose points if it's not. So one thing that's important is actually writing what you mean and not leaving things off. So as we carry, until we actually evaluate the limit, we have to rewrite this part. So I'm going to have to say the limit as x approaches 3, and then I'm going to factor this. I get x minus 3 in the numerator. In the denominator, I have x and x. 15 is negative, so my signs are opposite. And what are my two numbers? Positive 5 and negative 3. Okay? Make sense? We can factor. All right, so now I can reduce. And of course, that means that I have a whole when x equals 3, but it's not really what it's asking me here. So that's equal to the limit as x approaches 3 of 1 over x plus 5. Now I can use direct substitution. When you evaluate the limit, then I no longer actually write this. The limit as x approaches 3 of 1 over x plus 5 is 1 over 3 plus 5, which is 8. So it's 1 over 8. We good? All right. Let's look at number 3. We've got the limit as x approaches 2. So the limit as x approaches 2 of, in the numerator, when I factor, I'm going to have x and x. The 6 is positive, so the signs are the same. This is negative, so they're both negative. What are my numbers? What goes in there? How do we factor? Oh, there you go. Negative 2 and negative 3. Y'all worried me there for a second. Then the denominator I'm going to factor. X and x. Plus and minus. What are my numbers? 2 and 2. Okay, because it's a difference of squares, right? So then I can reduce. That leaves me with the limit as x approaches 2 of x minus 3 over x plus 2. Now I'm going to evaluate the limit. 2 minus 3 is a negative 1 over 4. It's a negative 1/4. Everybody good? All right. Number 4. This gives me limit as x approaches negative 4 of, all right, so the numerator, I'm going to have to factor by grouping, so I'm going to go off to the side to do it. I'm not going to say that it's equal to any of this, because it's not. It's just a little side note here. So I'm going to group those two. So that'll give me, when I factor out here, I'll get x squared times x plus 4. Then I can factor out a negative 1. Leaves me with x plus 4. So that gives me x squared minus 1 times x plus 4. Can I factor some more? Yes, because that's a difference of squares. I'll just do that as I write it in here. So it'll give me x plus 1 times x minus 1 times x plus 4. Denominator, can factor out a 2x, leaves me with x plus 4. Okay. Then I can reduce x plus 4 with x plus 4. That gives me the limit as x approaches negative 4 of x plus 1 times x minus 1 over 2x. So when I evaluate that, I'm going to get negative 4 plus 1 is going to give me a negative 3 times negative 4 minus 1 is going to be a negative 5 over 2 times negative 4, which is negative 8. So that gives me negative 15 over 8. Questions? All right, let's look at number 5 then. So I'm going to rewrite the limit as x approaches 6. Numerator, I will have x and x. The 24 is negative, so my signs are opposite. What are my numbers? Negative 6 and positive 4. Okay, so then this one, A is not 1. I don't have a GCF, so I'm going to come off to the side and factor by grouping. So 3 times 12 is 36. So I'll have 3x squared. It's two numbers that multiply to give me 36, combined to give me a negative 20. Negative 18 and negative 2. So negative 18x minus 2x plus 12. Factor out the 3x, leaves me with x minus 6. Factor out a negative 2, leaves me with x minus 6. So this gives me 3x minus 2 times x minus 6. And I can reduce and go ahead and finish this one up. We get 5 over 8. We good? All right, so let's look at number 6. I have the limit as x approaches negative 2 of, all right, so in the numerator, I have the sum of cubes. Sum and difference of cubes, something we got to be able to factor quickly and accurately. I get a binomial and a trinomial. What's my acronym I use for sum and difference of cubes? SOAP. And this is plus, so it's same, opposite, always positive. Cube root of x cubed is x. Cube root of 8 is 2. This one is x squared. The middle term is these two multiplied together. Last term is the second one squared. You go ahead and factor the denominator, finish this problem up. Get 3 halves? Good. All right, so let's look at a little bit of a different situation here. So I'm faced with the case again here, where if I substitute in 4, I'm going to get 0 over 0. That's a problem, right? But there's really nothing for me to factor, but I have square roots and I can rationalize. We are used to rationalizing the denominator, but when you're in a situation like this, you rationalize whichever one you can rationalize just to kind of get things going. In order to rationalize this, I wouldn't just multiply by the square root of x over the square root of x, because when I do that, I have 2 terms in the numerator. That'll take care of this square root, but then I'll just have another one over here, and I'm kind of going in circles. That's not how you rationalize. You rationalize using the conjugate. Okay? Conjugate is something that you learned in Algebra 2. So, conjugate. Right. So we're going to do just a random conjugate that's not that first. If I have x plus 3, and I want the conjugate. It's really easy to figure out. The conjugate of x plus 3, all you do is change that sign. Oh, spell correctly here. Change the sign. And it becomes x minus 3. Now that doesn't mean I go in here and I just change this sign. That means I'm multiplying. If this is what I have, its conjugate is x minus 3, we would multiply them together. And when we do that, what kind of situation do I have? Difference of squares. And it's important that you recognize it as a difference of squares so that it is easy to take care of when we're actually using it. Okay. Everybody good so far? All right, so let's look at what we're going to do here. I've got the limit as x approaches 4 of this function. I'm going to have to rationalize, which means I use the conjugate of whatever the square root part is. So the conjugate of the square root of x minus 2 is the square root of x plus 2. And I have to multiply by a factor of 1 so I don't change the value, so my denominator looks exactly the same. Okay? So then that's going to give me the limit as x approaches 4 of, so in the numerator, when I have this times its conjugate, remember it is a difference of squares. Difference of squares says you square the first term, that'll give me x, minus you square the second term, that's 4. In the denominator, I'm not going to FOIL those. I don't want to multiply them out, because remember our goal really is to factor, but we have to rationalize first. So I'm just going to leave it as x minus 4 times the square root of x plus 2. Like so. Then since I have that, I can reduce. That leaves me with the limit as x approaches 4 of 1 over the square root of x plus 2. Who's this from? All right. So then I can evaluate, which is going to give me 1 over 2 plus 2, which is 1 over 4. We're good? All right. So let's look at number 8. What do you think I'm going to use for the conjugate here? Exactly. Square root of 4x plus 6. Okay, so that'll give me the limit as x approaches 9 of, in the numerator, I'm going to have x minus 9 times the square root of 4x plus 6 over difference of squares, so I square the first one and I get 4x minus 36. And right now nothing matches, so I can't reduce anything, but I can factor out the GCF in the denominator. So this is going to give me the limit as x approaches 9 over, x approaches 9 of x minus 9 times the square root of 4x plus 6 over 4 times x minus 9. Now I can reduce, and I'm left with the limit as x approaches 9 of square root of 4x plus 6 over 4. Now that I'm there, I can evaluate. This is going to be equal to square root of 36 plus 6 over 4. So that's going to be 12 over 4, which is 3. What questions do you have? We all good? All right, let's look at 9. So my conjugate here that I'm going to use is going to be the square root of x plus 1 plus 1. I'm not changing the sign under the square root. I change the sign between the two terms. So square root of x plus 1 plus 1. So this is equal to the limit as x approaches 0 of, numerator will give me negative 3x times the square root of x plus 1 plus 1. Denominator, square the first term, get x plus 1, minus square the second term, get 1. Plus 1 minus 1 zeroes out, and then I can cancel this x with this x. So that leaves me with the limit as x approaches 0 of negative 3 times the square root of x plus 1 plus 1. Then I can evaluate. Give me negative 3 times, so 0 plus 1 is 1, square root of 1 is 1, plus 1 is 2, so my answer is just negative 6. Any questions? All right, on number 10, you write your conjugate down and get to this first step on number 10 on your own. Did we all get here okay? Make sense? Okay, so let's start cleaning that up. We'll clean up the denominator. We get the limit as x approaches negative 2. I'm going to rewrite my numerator. X plus 2 times square root of 14 minus x plus 4. And then that'll be negative x minus 2. What am I going to need to do next? Good. Take out a negative in the denominator, so this will give me the limit as x approaches negative 2 of x plus 2 times the square root of 14 minus x plus 4. And it is important that you rewrite everything like I am. It's all your equalities have to make sense with each other. Factor out the negative. You get negative, then x plus 2. Now, we can reduce right there, right? Then the denominator just has a negative in it, so I can bring that negative up to the top and have the limit as x approaches negative 2 of negative, then square root of 14 minus x plus 4. Now that I have that, I can evaluate. So I have negative, and then 14 minus a negative 2 is 16. 16, square root of 16 is 4, plus 4 is 8. So in the end, really, I just have negative 8. Any questions at all? All right, get to that first step again on number 11. Did we all get here okay? All right. So in the numerator, I've got a quadratic, so I'm going to flip it around where the x squared term is first. So I'm going to have the limit as x approaches negative 3 of, so give me negative x squared plus 2x plus 15 over x plus 3 times the square root 2x plus 15 minus x. Okay. So I'm thinking in the numerator, I'm going to need to factor, but I want my x squared term to be positive for me to factor, so I'm going to factor out a negative 1 in the numerator. That'll give me the limit as x approaches negative 3. And then the numerator I'll have a negative, then I'll have x squared minus 2x minus 15. And then rewrite my denominator again. Then I'm going to factor the numerator. So I'll get the limit as x approaches negative 3 of negative, and then I'll have my two little parentheses here, x and x. The 15 is negative, so my signs are opposite. My two numbers are going to be a positive 3 and negative 5. I rewrite my denominator. Now I have something I can reduce. So I reduce these two. And this leaves me with the limit as x approaches negative 3, x minus 5 over the square root of 2x plus 15 minus x. Now I can evaluate, and we'll get negative 3 minus 5, which is a negative 8. Negative 3 times 2 is a negative 6, plus 15 is 9. Square root of 9 is 3, then it'll be minus a negative 3. This is going to give me negative 8 over 6, which is a negative 4 thirds. Oh, wait, what did I do wrong? Oh, it's a plus. What did I do wrong? Oh, I lost my negative. Look, that's what you can't do. You can't lose your negative. Thank you. I was like, wait, I knew something was wrong. Couldn't figure out what I did. All right, let me back up there then. Dang it. Yes, this negative is very important. You have to carry it along. So now I will have a negative 8 over 3 minus a negative 3. So it does give me positive 8 over 6, which does give me a positive 4 thirds. I was even going to say that, and I didn't even think to say it, and I did it myself. Don't forget your negative. I forgot. All right, Any questions at all? We good? Okay, I think the concept is pretty simple, but you got to be able to factor and rationalize. If you can't do the algebra, it doesn't matter how simple the concept is. That's a lot of what goes on in calculus. Concept's very simple. You can figure it out. The calculus totally makes sense, but it's the algebra that's inside of it that you've got to be good at. I haven't been lying to you, I promise.